we understand what we're looking at, and we're able to do a few TI things, which we will then revisit on Monday. I wanted to make sure we at least got this tickled in the back of our minds, tickled. You're not going to have any homework on this because I want you to do your out-of-class exam for Monday. But as far as you now see your scatter plot and your best fit line going through it. Fair enough? So it's the same thing we saw in Excel. It's not as pretty. The one in Excel is much better. But the booklet will guide you through a very quick analysis of this. So why is this good? Yes, the Excel one is prettier. Why is this better? Why is this better? Well, it gives the best fit, but so did Excel. But why is this particular one better than that static image? There's a hint. The static image I had on the screen of the very pretty scatter plot, the very pretty red line with arrowheads going through it. Why is this better, Benji?
Because, you know, it was made from those data points so we can, you know, go back to our y equals table, like, hey, what would happen if we put an outlier here?
Because we now have a dynamic tool that we can explore around. Here's what I mean by that. You're in this screen. That screen. Yes, I know. Press the trace button right now. Now some of this is going to sound like, oh, it isn't Math 95. And you did. But we're going to redo it now because chances are you've forgotten quite a bit of it. When you press the trace button, we should all be sitting here. I see x equals 2, y equals 35, which is the first data point, 1992, 35 million uninsured. Look up top there, P1 colon L1 comma L2. What is that telling you? You're on plot 1, and plot 1 is pulling data from list 1 and list 2, L1 and L2. Perfect. And you can scroll left to right. If I go to the right, it jumps around on those points. It jumps back and forth on all those points. Yay. Very good, very good, very good. But suppose I want to get onto the line and do the exact same thing, the scrolling. How do I get onto the line?
Press up.
Or down. Very nice. So here's language I've used over the past. If you had me in Math 95, you've heard this before. I call moving left and right scooching, and I call moving up and down jumping. So you jump onto the line. Push up. Do you see how it just changed? You see how it just changed? Now the bottom says x equals 6, y equals 39.4, but up top it says y1 equals 1.05x plus 33.1. Fantastic. You're now on your best fit line. Now practice jumping between. There's the data, there's the line. Data, line, data, line. Now, get back on the line.
I don't know what I did, but
I'm not jumping.
Mine's
Yeah.
barely moving now.
Oh, well scooch. So like this?
Yeah, yeah.
Like that? That's what it's supposed to be doing. It doesn't move. I was jumping, not scooching. So jumping just goes from the plot to the line, back to the plot. When you move left to right on the line, it only increments by, what's the increment? About. What's it incrementing by? Ish. About 0.1. It's not a very pretty number. It's not a very pretty number. And you can make it prettier. I don't care about making it prettier because we're not going to use this screen all that much. But in 95, you probably learned all kinds of tricks like Z decimal, or how to set up, maybe you did, maybe you didn't. It depends on who you had 95. But don't worry about that so much. Just make sure you can scooch. You get left to right and up and down. Does that make sense? Is that fair? So now here's a trick. This is a cool trick. You're on the line, and let's suppose you wanted to know how many uninsured people there were in 1997. Now clearly, we don't have that point in our data, correct? On your plot, it goes 98, 96. So it's somewhere between 98 and 96. Now using our data, we can kind of approximate it, can't we? Because in 96, there were 39 million uninsured. And in 98, there were 41 million uninsured. So logically, you could estimate how many uninsured are there in 1997. Approximately 40 million. If it goes from 39 to 41, and it's approximately increasing linearly, if it goes up 2 million in 2 years, it's going up about 1 million in 1 year. And the slope tells you that, right? That's what that slope tells you. It approximately goes up about 1.05 million per year. Fair enough? Fair enough. Good-ish. And that's great for estimates. But what if you need a more precise result? What if you need a more precise result than that? Now, that's where the model comes in. Everybody do this for me. Everybody do this for me. Press the y equals button. So you're at this screen. As soon as you run the linear regression, you don't need the scatter plot anymore. The scatter plot really is only put on so you can look at that and go, you know what? That looks like linear data. I'm going to put a scatter, I'm going to put a line through it. So it's basically, a scatter plot is only a tool for your eyes to say, that looks like a line. Eventually, they won't. They'll look curvy, they'll look like this, and you'll have to decide, oh, that's curvy, or that's a quadratic, or that's an exponential, or something like that. Right now, it's going to look like lines, and we're happy. So turn the scatter plot off by putting your cursor on top of plot 1 and pressing enter. See how it's unhighlighted now? Now press graph, and you'll see just your line. Now I do have a problem with this a little bit, because now you see a line going through a screen with absolutely no labeling on it whatsoever. That does frost my donut a little tiny bit. I'm not a huge fan of graphs with no labels, because I don't know what am I looking at? Is that y equals x? Is that y equals 2x plus 12? Is that y equals 18x minus 300? I have no idea what the hell it is. But press trace. As soon as you press trace, okay, there's my line. It's 1.05. Now once you're here, remember the question I asked a few moments ago? How many uninsured were there in 97? Once you're tracing on the line, you can just type the number 7. And you see how it says x equals 7?
How did you?
I just press 7. And then it pops up x equals 7.
Oh,
And then when you press enter, boop, it leaps to the point on the line where x equals 7. And it tells you in there you got about 40.5 million uninsured. So when we said 40 million we were issuing, we were off by about 500,000 people. 40, now, again, these are all estimates. All these things are estimates. So to be taken with a proper size grain of salt. But if you need more precision based on your model, that gives us more precision, doesn't it? How about 1993? How about 1993?
Enter
So
3.
you just type 3, press enter. In 93, about 36.25 million. Which hopefully, again, makes sense, because from our data it went from 35 to 38. 35 to 38, so you'd think that's 3 million over 1 year, be about 1.5-ish. A little bit on the low side, Fair?
Has it already calculated, like if I typed in x equals 50 right now?
Now, Benji asked a very good question. I asked you guys a question last time.
It says
How many uninsured right now? 2013. What do I have to type in?
23.
23. Everybody try it. 23. Enter.
You need to expand your one.
It doesn't go that high.
Now, problem with this, and this is a TI limitation for whatever reason, you can only enter data values right now that the TI can see in its screen. And that's a pretty limited window, if you think about it. And we're going to use these terms again in class on Monday. In other words, you can only interpolate using your data. Now when I say interpolate, we'll talk about this more in class on Monday, I promise. Interpolation is when you pick a data point to analyze within the data you already have. The data we have goes from 1992 to 2000. As long as we're picking values in between 92 and 2000, we're interpolating. What did we just try to do by typing 23? We tried to extrapolate the data. In order to extrapolate the data, there's one of two things you can do. Number one, you can expand your window to make the line go out further to see x equals 23. That's one thing you can do. So if you use your Math 95 skills, we're going to quit this. I'm going to go a little quickly now, and it's only because I'm trying to show you two ways. This is not my favorite way to do it, but this is probably the only way you know right now. You would hit your window button. Remember doing this in Math 95? Going to your windows? The largest x value it sees right now is 10.8. We've got to see 23, right? I'm thinking maybe 25. Give it some wiggle room. Just my personal opinion. 25. And y max, I'm going to bump that up correspondingly too, because I know, based on my model, every year it picks up 1 million people, and it started at 33. So I'm going to get like 60. See if that gets it high enough. And then just press graph. There's my new line. It looks exactly the same, doesn't it? But check this out. Watch. There's the original scatter plot. We just extrapolated out for another 20 years past that, or 15 years past that. Now, if you turn your plot back off, now you can press trace and type in 23. Just like we did with 1997, just like we did with 1993, type in 23, and it's going to approximate about 57.25 million people uninsured in 2013.
You just
There-
go to trace.
Yes, ma'am, but there's an easier way. Dory, there's an easier way than doing all this finagling with Windows. And we're out of time now. We'll do it on Monday. Cool? I got some more things that's what I want to play with, so we can really practice this methodology. Okay, doke? Friends, rock on, have a great weekend. Do your out-of-class exam. If worse comes to worse, if you can't get into that Google spreadsheet, what are you going to do? You're going to write your 5 values down. And I'll figure, I just sent an email, email to the CIS department asking them to give me a solution. We'll see. I don't know.